Okay, this is going to be an interactive notebook for theoretical and experimental probabilities. You're going to use quiz 9, IHL X1. So theoretical and experimental probabilities go like this. You have a definition of event, sample space, and favorable outcomes. So an event is basically something you're going to do. Like say we roll a dice. Or in this case, we're going to say roll a numbered cube. So if you roll a number cube and say I get a 6. So I'm going to roll a 6. I'm now going to talk about the sample space. This is going to be the faces of the cube. So each face of a cube has a number. So our sample space is going to include the number 1, 2, 3, 4, 5, and 6. My favorable outcome is going to be the number that I roll. So favorable outcome is a 6. So we're talking about the sample space. The sample space is actually the number of possible outcomes. And the favorable outcomes is basically going to be the number of favorable outcomes. And so when we're talking about the outcome, we're saying, okay, what can happen and what does happen? So the theoretical probability is, say, probability of the event, and it's going to be number of favorable outcomes over the number of possible outcomes. So in this case, you can say that your sample space is going to be your denominator, and your favorable outcome, or the possibility of outcomes, is going to be your numerator. So say that we went back to this and we said my event is a 6. You're going to say P of 6 equals the number of favorable outcomes. There was only one, because there's only one 6 in the sample space, and the number of possible outcomes, which is each item in the sample space, so it's 1 out of 6. Okay, so let's talk about the theoretical probability range. You're going to have from 0 to 1. We know that 1 is certain. We know that 0 is impossible. Equally likely to occur or not occur is half. If we look at this as a fraction, it's going to be 1/2. Okay, so let's go ahead and look at a couple of problems. Okay, our solar system has 8 planets in order from greatest distance from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You will randomly draw one of the names of the planets and write a report on this planet. What is the theoretical probability that you will select a planet whose distance from the sun is less than the Earth's? Okay, so it's from least to greatest, and I'm gonna go 1, 2, 3. It says that it wants the probability of a planet which is less than the Earth's distance. The Earth's distance from the sun. So we know that we're going to have a total of how many planets? I have a total of 8 planets. So number 8 is going to be the number of possible outcomes. And then we have the number of favorable outcomes, which are the planets that are closer to the sun. So that's going to be Venus and Mercury. So then that's going to be 2, which equals the number closest to the sun, or the planets closest to the sun, or closer than Earth at least. And we're going to make a fraction of that. So our numerator is going to be 2. Our denominator is going to be 8. When I simplify this, I'm going to get 1/4. Okay, so in problem 1, what is the theoretical probability that you will select a planet whose distance from the sun is greater than the Earth? So we're asking who's greater than the Earth. So in this case, you're going to say that your probability is going to be greater than Earth. We know that there's 8 possible outcomes because I have 8 planets. So I have 8. And then the number of planets further in distance than the Earth are Mars, Jupiter, Saturn, Uranus, and Neptune. So that gives us a total of 5. And you always have to do lowest terms, and that's your solution. Okay, so let's look at complement of an event. A complement of an event is basically something that's not part of the event. So it's all outcomes in the sample space that are not in the event. So it's all outcomes in the sample space that are not in the event. These 2 problems are going to talk about something that's not in the event. Okay, in a taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 samples of drink B, 10 samples of drink C, and 10 samples of drink D. What is the probability of participant not getting drink A? So we're talking about the probability of not A. And we're talking about the number of drinks. So you're going to say that since drink A is 20 samples, so you're going to say drink A is 20. And all drinks equal 50. So in this case, since all drinks equal 50, if we're saying we're not going to get drink A, so it's going to be 50 minus 20 equals 30, that means that this is going to be the number of possible outcomes. So I have 50, and this is the number of not A. So that's 30. So it's going to be 30 over 50, and that simplifies to 3/5. And you have to have lowest term. So number 4, suppose a taste test is repeated and with the same number of samples of drink A, but with more samples of other drinks. What happens to P not drink A? So we're going to talk about the original number. So I can already tell you that your probability is going to increase. And the reason why it's going to increase is because you're going to have to subtract it from the whole. So you're going to say the probability of not A again. And we're, again, the same number of samples. We're going to say that that is from the whole. That's going to equal negative 20. And say we're going to have a total of 50 drinks. Plus more, and we don't know however many more there are. So it's going to be the sample, so the number of possible outcomes plus X, because we're not sure of how many more samples are. So this is going to include more samples. So it's going to be P naught A, 1 minus 20 divided by 50 plus 10.